So this is the second session of Chapter 4, and we're going to tackle something today that's probably just one subject, which is like access modifiers, and it's because it might take quite a while, so we'll probably just concentrate on that one thing in this session. Because in the last session we talked about the access modifiers that you can have on methods. So here I've got this. So for example, if we go to some of these classes that we'll be using in a minute, this parent class here, it's got a method here at all of those different levels: public, protected, default, which doesn't have any keyword, but it's just, if it doesn't have a keyword, it's default, and private. So we talked about like the different access modifiers in the last session, and this session we're just going to sort of go through the implications of what that really means. And I think the reason this is going to be quite a challenging session is that I think you can't really look at that fully unless you also understand inheritance. It's kind of, linked with that very much. So just have a look at a little bit at inheritance and then sort of apply it to access modifiers. And again, the good thing is, like I said last session, a lot of this stuff is actually a revision of things we've already touched on. Like we already know pretty much what access modifiers are, and we know a bit about inheritance. So I mean right from the start, Chapter 1, we did our animal class, and we already done inheritance. There we've got this animal class here, and all these other ones inherit from that. So we've got properties here and methods on the animal class that the other ones inherit through the inheritance chain. So most of these animals are so far pretty simple. We might be adding more as we go through the course, but like most of them, are just sort of basically extend it and call the constructor on the parent, just passing in what type it is. So an antelope will always be an antelope, but the name, that's what will be unique for each one. So all these animals, they're fairly straightforward, and the reason we do inheritance, of course, is to save rewriting things, because things that you write in the animal, you don't want to, if they're generic, you don't want to be writing it for every single animal class. That it gets them through inheritance. So that's something we've dealt with quite early on. This one, duck. Now that duck extends animal, but this is kind of like a special case because it's being deliberately coded to demonstrate inheritance and access of different variables on it. So if we just have a quick look through it, so it's got a logger there, because we obviously we did a session on configuring a logger, and here's its constructor, and it's got this method called eat. Now that's an override from the superclass, because the superclass says you must override this abstract method eat. We haven't covered abstract methods or overriding yet. They're ready for when we cover it, but still it should be fairly clear what's going on there. We've got an abstract method in the parent, and we're overriding it here in the child. And the reason for that, of course, is all animals have different eating habits, so you wouldn't want to define that in the superclass. You'd want them all to define their own eating habits. And you do want them to define their own eating habits, because all animals have to eat, of course. So in the superclass, you're saying you have to have this method eat, but it's not down to me to tell you what that method should be. So, and just obviously it's just a demo, so all it really does is print out this particular duck is eating. So to demonstrate sort of like inheritance and access to methods, members within the inherited classes, just put a couple of methods in this class to demonstrate that. Let's just go through one by one. So I put this method in called feed. So the duck is going to feed itself. So we come into this method, and to feed itself, it eats. So it calls eat on itself. So it's calling eat on itself. You'll notice there's no object reference or anything like that, just calling eat. And what that implicitly means is it's calling it on itself. So implicitly there's a this there like that. It's the same as doing that this keyword. But it's calling it on itself. And then once if you imagine that duck is the mother duck, she'll then want to feed her ducklings. So we pass in some ducklings here, and this is from the last session. They're just a revision there of var args. Remember, we're saying here this mother duck has ducklings, and we don't know how many she may have, so you can pass in as many as you want, comma separated. So, and then what the mother does is for each of those ducklings, they eat as well. So this time it's gone through an object reference there of the duckling itself, an object reference. So here it's like an implicit this reference, and here it's on a reference of another instance of an object of the same class. So hopefully that's fairly clear there. So now what we do is we can call methods that are inherited from the parent. So if you remember, one of the methods in animal is getName, I think. getName, there it is. It's a public method, getName. At this level, everything's going to be public just to make it easy. Then in this duck example, when we go to the more complex classes, we will play around with different access modifiers. So here, it's very similar method here. We're just going to log the name here. Exactly, very similar method structure to this. First of all, the mother logs her own name, and again it's getName like that. So that's calling it from the method on the superclass that gets inherited here. Again, it's very much the same as using a this reference there. It's implicitly got that this in it, but you don't need to have it. And then exactly the same thing with the ducklings, and calling them on the duckling reference there. So this for loop, the shorthand for loop, you're saying for every duckling in this ducklings varargs, this ducklings array if you like, create a temporary local variable called duckling, and then call the getName on it. So just to take it to the extreme, every single class inherits from the class object. So, and one of the classes in object is equals, as you know, equals here. So let's do another method here, a check for a duck. So we're going to pass in a mystery duck there, and then this duck's own ducklings. So similar pattern to before. First of all, she's going to check herself if she is the mystery duck. And then she'll do the same for the children. It's exactly the same pattern in each of these three methods, but this is a method, this eat method is a method we've defined right here in this class. The getName method is a method in the superclass, and the equals method is in the absolute daddy of all classes, the object class. And once again, this here has an implicit this reference, but we don't need it. So it's like that, this getName, but we don't need that because it's implicit. So if we actually run this, so these are all instance methods, public instance methods. So if we just run it by creating a main method here, so we're going to say we're going to create a mother duck and 3 ducklings, and we're going to say to the mother, call that feed method, and pass in those 3 ducklings. So that'll go into that varargs variable there. So let's just kind of just comment the next lines out first, just so we can do one line at a time, and just run that, and yeah, and that should pull that up. Yeah, so all of them are eating. So there's the mother duck, and there's all the ducklings. So if we then just go to the log one, so now it's calling a method in its superclass. That's the class animal, and it does them fine. And finally, it's going to just call the method on the absolute superclass, the object class, that equals method. And it's going to pass in a mystery duck. We've created a mystery duck called Dave there. We're going to say, is this mystery duck either you or your ducklings? So pass that in, and there we go. It's saying that none of those are the mystery duck. So what? Again, this is a bit of revision from earlier in the syllabus. If we create that mystery duck to actually point to one of the ducks that are one of our ducks, duckling 2, and run it again, they're pointing to the same object now, these 2, and so Shirley is the mystery duck now. So just it's just to show inheritance and how we access members in super classes and super classes right up to the object class. So now we have to go to it in a bit more detail, and there's this package here which looks a bit complicated. This Access Modifiers and Inheritance package, because it's got quite a few classes in it here to demonstrate this. I've kind of named them all to describe what we're trying to show here. So you see you've got a parent class and a child and a grandchild. Independent, that means it doesn't inherit from anything. And I've kind of you can use underscores. If you remember from the naming conventions, you can use underscores, even though it's not usually recommended. I thought I'd use it in this case because the first letter tells you what package that thing's in. So these are all in package B, these are in package A, and this is in package B, sub-package B. So we'll look at this now and see how inheritance and access kind of works in that kind of environment. And there's a little diagram here actually there, which kind of shows those classes we're going to look at. We've got 3 packages: package A, package B, and package B, sub-package B. So we've got these 3 classes here. We've got a grandparent, if you like, here, a parent and a child, or rather, parent, child, grandchild. This open arrow shows an extension here. They're all in the same package. Also in this package B is a completely independent class that has nothing to do with these 3, but it's in the same package. Then in this sub-package, grandchild BB also extends from that one. And from A, we have another class extending that one, plus an independent class. So we might refer back to that diagram if we want to, but that diagram represents all those classes there. And it looks a bit weird to start with, but if we just go one by one, it should hopefully become clear. So if we start in parent class here, so also I put because it's some quite complex themes in there, so I put quite a few Java docs in these classes if you want to access them and have a look and read these things. And it talks about the different levels of public, protected, private and default methods here. The good thing about it is that public and private are really easy to understand. So for a public method, any other class anywhere can access it and run it anywhere. As long as they've got access to your class, they can access and call that method. So that's an easy one. Private is also easy. It's only ever accessible in the class in which it's defined. So if we look at zoo animal here, we've made these things private here in animal. Right at the beginning of chapter 1 we did that, and that's because we don't want any other class messing with these individually. We don't want any other class just thinking they can come in and change this name or type. We make them private here, and we only allow access to them through public methods that other classes can call. So you can control access to these by making them private and then providing public methods. So let's go back to that one again. So public and private is easy to understand. It's basically public, anyone; private, no one except the class in which it's defined. So it's really the nuances around protected and default that are tricky in this area. But basically, default, so that's the one where you don't physically have a word as an access modifier. It's kind of considered as it's often called package private. So it behaves like a private variable to any other class in the package. So if you see here, for example, in this animal package, there's quite a few classes, more 10 or so. So any private variables, any default variables or methods in here are accessible to all the others. So it's like package private. Protected, it has this. So protected goes one stage further. So protected is also accessible to anything in the same package, but it's also accessible to a subclass that you might define in another package. So you might immediately think, why, for example, in our animal class, why would you define a subclass that's in another package? Why, for example, let's think of one that's not there, deer. So there's no deer there. And you might think, well, if you did define deer, you would logically put it in this package. But actually, you can soon get past that. That's simplistic. If you think that the object class, everything extends that, and they're all in different packages from object, because object's in java.lang. And for example, if you imagine we've defined all this animal logic, if you imagine that for a zoo, if you imagine that a vet came along and wanted to use animal classes, but he didn't want to associate them with a package called zoo because it's not appropriate, he might create a package called vet or veterinary, whatever, a different package, that vet related, and he might want to extend an animal class, but in a different package because he doesn't want the word zoo appearing in his package. It doesn't seem appropriate. So you can absolutely, and you always, all the time, see subclasses in different packages. So so this list here, this Java doc here, it'll be worth referring to after this session, because it's all very well just reading it, but actually seeing it in action, you can't, is the way to do it really. So if we start looking at this now, this first class is quite simple. We've got this class called BeatParent class. Now that kind of implies to you that it's going to be a parent of other classes in a while, and we saw that on the UML diagram. And of course, it is itself a child class of object. You can even write that in if you want. You can even write it in, but you never have to because it's done implicitly. But you can do that if you want. It still compiles, but you don't have to do it. It's implicit. So you could say that is a parent class. Other than object, there's nothing above it in its inheritance tree. And what it does, we've got in the habit of putting these loggers in now rather than the system outs, right? So that the logger is there. But then we've got 4 methods defined, and they define these 4 different access types. So we've got a public method, a protected, default. So remember, there's no keyword there. If we actually we can't put the keyword default there because that has another meaning in Java. We just don't bother with the word at all, and it's inherently default. And a private one, and they're all going to print out, the method name. So public parent method, protected parent method, default parent method, private parent method. And then you'll see this pattern appearing in all these test classes. So now what we can do, and also we won't be running an awful lot of things in this session because you can tell just by whether it compiles or not the principles we're trying to illustrate here. So if we, so I've got this method called check access directly. So what do I mean by directly? I mean you're not using any object reference to call them. You're calling it on the object itself, so through an implicit this reference. So so we've got these 4 methods, and because they're defined in this method, it's no problem at all. We can call them all, and they all compile. That's fine. That's as we'd expect. And there's a second method here, and as I say, this pattern will be repeated in these other test classes. Check access via an instance. So here we're just calling it on itself, so implicitly on the this object, which is the instance itself that you're talking about. But here we'll actually create an instance of my class. So we're called BeatParent class. So we're creating an instance of BeatParent class. So if you think on the heap, BeatParent class is there as like you can imagine a big circle on the heap. Then it's got another BeatParent class kind of inside it here that it's created itself. So new, it'll create another object on the heap. So and here we're calling the same 4 methods but through that object reference. And again, that no problem with any of them. They're all defined in this class, so they can all be accessed through this class, whether directly or through an object reference. So far so good, so fairly simple. So let's now go to BeatChild class. So this one, again, quite a bit of Java doc in there just to explain the principles we're looking at here. So it extends the class we're just looking at. And so we've got the logger again there, but just to illustrate it fully, as well as so we've got those same 4 methods again. IntelliJ's kind of auto-formatted it for me, which I don't really want because I want them to be shown properly in their own right. They're exactly the same type of methods, but instead the word child there instead of parent, just so we can identify, we can distinguish between that one and the one in the parent class. But they do exactly the same thing. They just do a logger debug of what the name of the method is. So in the parent class they're all called parent, and in this class they're all called child. And but as well as that, we've also got, so these are methods, but we've also got here variables, and it's just to show that exactly the same principles apply to just variables as well. So we've got the 4 levels of access here, and I've just they're all ints, just it doesn't matter what type they are. It's just for illustrative purposes. They've all been given a value, and so we've got our 4 methods and our 4 ints. Then we're going to look at those two methods again, similar to what we looked at in the last class. So here we are. We're calling these directly on itself, just to be different. This one, I put an animal in that. I say, you can pass an animal in as a parameter. Just don't know why really, but just to make it slightly different. But anyway, calling them directly again through an implicit this reference, you can call them all. So that's no problem at all. But here is where we just start to see the differences creeping in, because notice these have all got child in the name because they're declared here in this child class. But these are being called through inheritance. Again, you've got the implicit this reference, but these methods are all inherited from the superclass, which we looked at previously. And as we expect, we can't call the private one. We can't call the private one because that can only ever be accessed in that class itself. But because we're in the same package here, we're in the same package, and we inherit from this one, we do get the protected and the default one. So that's no problem at all, accessing them directly through inheritance. So now if we access them through an instance, so again, this is the class where it does get a bit complicated because they've all got similar names. So we're in BeatChild class, remember. So here we're creating an instance of BeatChild class. I'm calling it an instance of my child class, and I can access all of those 4, the methods and the variables there. Now if I create an instance of my parent class there, I can access all of them except that private one again. And it's because we're in the same package. We can get default and protected methods because we're in the same package there. So that's shown that one. Then this grandchild class really just shows exactly the same thing, but it tells you that it doesn't really matter how many generations you have, the same rules apply. So what I've done in this one, I haven't actually bothered defining those 4 methods at this level again, because we all know what's going to happen. If we define those 4 methods here, then we're going to have no problem accessing them here, all 4 of them. We've seen that in the previous 2 classes. I haven't even bothered putting them in. So what we're going to do now, we're only going to be looking at the methods on the parent and the grandparent. So here we are checking them directly, i.e. through the implicit this reference. Again, we can call all but the private one, just as the same behavior as we saw before, and same with the variables. And this is on its grandparent now, going up a level. So if you remember, this one is defined in the parent, this one in the child, and this is the grandchild. So that here we're 2 generations up now, but it's exactly the same rules apply. And even if you had 100 things in the chain, the same rules would apply. So just to really sort of hammer home the point. And we see exactly the same thing if you access it via an instance variable. So here I have my own class here, and I can access. Now if I'd have defined those methods in this class, I could have hit all 4 of them, but this is through inheritance, remember. So these have been inherited from the parent, and so the only one not accessible is private because we're in the same package. Exactly the same with the variables. So this is an instance of that parent class here, BeatChild. It's called child class, which is confusing, but it is actually a parent of the class we're in at the moment. So and again, because we're in the same package, we get all of those through inheritance except the private one. And again, just to labour the point, through the grandparent one as well. And just to show as well, those variables, these ones here, they were defined in the child class. So if we this is obvious really, but just to show, of course you can't access them on the grandparent, because they're not that's going the wrong way up the inheritance tree. They only appear from child onwards. They're not in parent. So just okay. So those 3 classes so far have just shown us that they're related. Those 3 classes. You can only access private private members in the class in which they're declared. But as long as you're in the package, you can access anything else, either directly or through an instance. This one is independent class here. So this one doesn't inherit from any of those three we just looked at. And actually, it might be slightly surprising what you see here, because again, I've only bothered to bring one of these other three classes in here because they're all the same regarding this one, because none of them are on its inheritance tree. So the only thing that these have got in common with independent classes is that they're in the same package. So we'll take BParent class. It could have been any one of the other two as well. And actually, you can see that you can actually call all the members except the private one. This has to be via an instance, because of course this doesn't inherit them, so you can't get it through inheritance. You have to do it via an instance of one of those other classes. So actually, the behaviour of this is actually similar to those other three. They can access everything except the private one, and that's what we've seen in all of these. So the big take-home message from this one is it doesn't matter if you're a subclass or not. So like grandchild is a subclass, and it can access everything but private methods on other classes in the same package. This one isn't a subclass, but it can still access everything but the private ones. The only difference is, of course, it doesn't get any of them through inheritance. So that's why it's only got this one method here. It doesn't get them through inheritance. It just gets them. It can only do it by creating a variable of that type, completely unrelated to it. So we've got through half these test classes now. You can see this is quite sort of it's not exactly complicated. There's a lot to sort of get through, finer principles. So far all we've seen is that we haven't really looked much at these two, protected and default, because as long as you're in the same package, one of the golden rules, as long as you're in the same package, you'll always be able to get access to these protected and default. But now let's have a look at this BeatGrandchild class. So if we have a look at that in this diagram here, that's in a different, it's actually a sub package of package B. It extends from BeatChild class in the same way that grandchild class. Their names are very similar. This has got two B's in it because it's in a sub package. So if we look at it there it is. It's in package B, but it's in a sub package of package B. So let's have a look at this one then. So this time, if we try to access it directly, we don't get the default one either. We don't get either of those two. And the same with the methods here. Same with the primitives, the fields rather. You only get the protected ones. So here the rule is that if you're in the same package as the other class, you can access everything but private. Here we're not in the same package. We're in a sub package, but via inheritance, we do get the protected one. So if you're in a different package but you extend another class, you get the protected ones and the public ones. Of course, you always get the public ones through inheritance. So it's exactly the same here. We're calling child method there. Here is the parent method. So relative to this class, this is its parent and this is its grandparent. But the same behavior. It doesn't matter how many levels. You could have 10 levels of grandparents there. It doesn't matter. It's going to see the same behavior there, like that. And checking via an instance, we see exactly the same thing. So here we're seeing. So this is called BeatGrandchild class. So this is an instance of itself now. Again, it can only get those two, protected and public. And it's exactly the same on its parent class and on its grandparent class, but there's a difference here. If you look at, so here we've got an instance of this class itself. This class itself is a grandchild class. This class itself, and it inherits that protected method through inheritance. But what you've got here, this is a class. This is BeatChild class. This is the superclass of this class. But we're treating it here as just, it's almost a red herring that this is the superclass of the class we're in, because we're treating it here just as any other object. So even if we'd see the same thing if we got an animal object here. We can of course call public method on it, but we can't even call protected methods on this anymore. Now this and it even says in the study guide, this thing we're looking at now, this principle we're looking at now, is one of the hardest ones to understand in the entire course here, because we've already said that through inheritance you can access protected members, and we've shown it here. We're accessing a protected member here, which comes from this class, and we're seeing it through inheritance here. And here we're seeing it through an object reference of this own class of itself. The reason it doesn't work here is because here we're accessing it just through an object reference of that class. It doesn't matter. It's a red herring that happens to be the parent class here. It's just any other class, because you're not accessing it through inheritance. You're saying it doesn't matter that the class I'm in is a child of this class, because I'm not treating it that way. I'm treating it directly as itself. I'm going up the inheritance chain and just treating that object in isolation on its own. And in that case, I can only access its public methods. Through inheritance, if I treat myself as an inherited child of that class, I can access those methods here and here. But when I try to access that class just as an instance of itself, with no relation to the fact that it's a parent class, you can't get the protected members. And this is likely to take a few times going over this to fully understand it, and we have a simpler example in a minute with some nicer names, like we've got a goose and a duck, to show that in a minute. But first time round, that does take some understanding, and the same rules apply of course to the grandparent class. So that's this package dealt with. So what we find, this class here, so if we look at the diagram again, we'll now look at this class here. So this is also a subclass of BeatChild class, and it's in package A. So I think rather than going through this line by line, what we find in this one, I'll just skate through it. What we find in this one is it's got exactly the same behaviour as the class we just looked at. So this class here, if you remember, through inherit, so through this class, BeatGrandparent class, I'm now looking at this one, but I'm talking about this one. Through inheritance, because it's not in the same package, through inheritance it got the protected, but not the default one. And when we dealt with the reference of itself, it could call the protected one as well, but nothing else, nothing of less access than that. But then when we went to the parent class, we dealing with it independently, we couldn't do that. So basically these two are actually exactly the same as each other. The only reason that was put in is to show that being a sub-package, like this is, gives it no special privileges. So being a sub-package, you might as well be in the animal package. You might as well be in a completely unrelated package. Being in a sub-package gives no special privileges. So that class behaves exactly as that one there. That they behave exactly the same there. So if you understand, the behaviour exhibited in both those classes, if you actually understand that, why you can get the protected one through inheritance, but you can't access it through an instance variable, then you've really understood this well. And as well as understanding this towards the exam as well, the understanding inheritance and like access of members is obviously fundamental to object-oriented programming in general. So it's a great thing if you can really sort of go through this and understand this. And now we're left with the final one. It's another easy one, thankfully. It's A independent class. So we had B independent class, and if you remember, B independent class could access all the public, protected, and default members of all these other classes, even though it's not related to them. So A independent class. It defines its own set of integers and its own set of members and methods at all those different levels. And unsurprisingly, it can access them all because it's defined in the same class. either directly with the implicit this reference or indirectly through another object reference. So this is like another instance of itself, another instance of its own class. But when you try to get any other class from a different package, so it's got an instance here of BeatChild class, it's only going to be able to get the private ones, because it can only access these through it can only have access to obviously it can't access private. That's we know that by now. But it could only access these two if it was either in the same package, well it's not, or inherited from them, and it's not. So quite sort of understandable behaviour in that one, really, that it can only get that one. So there's a lot to learn there, and so I would recommend just looking over that again. As I said, there's a simpler illustration of it here. We've got and these are adapted from the study guide. So if we look at bird here, this is a nice simple class. So it's a public class bird. It's got a protected member, and protected field, and a protected method called floating water. So it's a floating bird. So very simple class. Now in another package, so as I said, it doesn't matter that these two are sub-packages of the same package here. That makes no distinction at all. Either you're in the absolute same package or you're not. There's no sort of halfway of being in sub-packages or anything. Either you are or you're not, and it's not. So Goose is not in the same package. But it does extend it. So if you apply those basic rules we thought of before through inheritance, well, if it was in the same package, it would get all the public, protected, and default members. But it's not in the same package, so it only gets the public and the protected members. Actually, there are only protected members. So I say this is a slimmed down, way of showing this. So it can call floating water directly. So that is a protected method on its superclass, which it gets access to through inheritance. So it can call that no problem. It makes an instance of itself, and it can call that method on the instance as well. So just a much simpler version of what we were showing in all these classes here. There. But then what it's trying to do here, that's this method. It's helping a goose to swim, or help goose swim it's called, but it's basically calling those protected members on itself or another instance of goose. Now what it does, it creates references to bird itself, which is there. This is exactly analogous to what we were doing in those other examples before. And it's saying, well, bird is my parent, therefore I get access to its protected members, therefore I should be able to call floating water on this bird. But you can't, for exactly the same reasons. And that's because here it's kind of irrelevant. It's irrelevant that this is its parent, because you're just treating it as a bird. An easy way to... It's confusing that we're doing this in this class, because if you did it from any other class, say I don't know, one of our array tests, a class that we used a few sessions ago, then this behaviour would be obvious. But it's a red herring that we're actually in a subclass of this bird, because it's completely irrelevant. We're just treating it as a bird, nothing to do with goose itself. We just happen to be in the goose class, but we're treating it as a bird. And the rules are, you're in a different package from me, and you've got a reference of me. Therefore you can only access my public methods. Only if we were dealing with an actual goose class here would we be able to access that. And I think it was just exactly the same again there. It's like we're creating... Okay, so this is further nuance as well, because here we're saying we're creating a new goose, right? So goose is this class, and we just showed here if we created a new goose, we can hit that method because we're going through a reference of goose here. But the difference is we're assigning it to a bird, so we have to treat it as a bird. We're saying that the type of this reference, another, is bird. Even though underneath the hood it's a goose, we have to treat it as a bird. So it's a similar principle as when we were in the animal package here. We sometimes assign these, like a tiger, to an animal reference. We couldn't then treat it like a tiger. We could only treat it as an animal because we assigned it to a tiger reference, to an animal reference. It's the same here. So if that was a goose, of course, that would work. But so that in fact, this very difficult point we're trying to get across here, these two lines here probably illustrate it as clearly as anything, because if we change that, if we just did, I'll put that in there and comment it out, and you can just sort of swap between the two to show that principle. But that won't work because you're having to treat it as that class. So that probably won't be, if this is the first time you've gone through this stuff, it probably won't be clear at that stage. It'd probably be quite confusing, I imagine. But please review it and maybe look at this video and maybe read the book, and you know, and if it will go in eventually. It's just one of those things that's quite a difficult concept to understand. But that's basically done. Following on from, we looked at method signatures last week. We introduced those 4 types of access: public, private, protected and default. And now we're showing the implications of that in inheritance. So I think there was one other thing to show. Yeah, like there's a few sort of small points you can make in some of these classes as well. I'm trying to think. I think I commented out a method in here to show something later. Doesn't matter. I can do it again here. So you can. So here we've said, for example, that actually, no, we can't call private child method because it's in another class. It's defined in another class. But say you did want to call a method called private child method, there is nothing stopping you, of course, actually creating your own. So you could do it here. You could just do it there, like that. Which method? Yeah, I know. I've done that inside another method, so I take that out of there and put it there, and that suddenly compiles. But that's not an override. It's not an override, and it's not calling the superclass. It's just you just happen to have another method in your class with the same name as one on the superclass. If you try to say, well, that's an override from the superclass like that, it'll say, oh no, it isn't, because you can't see that in the superclass. I don't want to complicate things too much. Overriding is done in some detail later on, but now that doesn't compile again. So there's that's that one. Yeah, so that pretty much covers access modifiers and inheritance. So the next subject we'll do in the next time is all about statics, which we started in the last session, but we'll do a bit more on that in the next session.